Hi, we're in chapter 25 of Halliday, Resnick, and Wofker, and we are now going to do a problem on equivalent capacitance. So what I'll do is I'll walk you through this problem, and as I go along, I'll use this highlighter to show you where I am on the page. So from the previous lecture, you should see two important formulas for capacitors in parallel and in series. These are the formulas you should know. If you don't remember the derivation, you should go back and review it. Now, using these formulas, you can now tackle this problem over here. So, on your paper, draw this circuit, and you see three capacitors. The values are shown here. And what you want to do is calculate the equivalent capacitance. So when you draw your picture, try to make all of your wires either horizontal or vertical. Okay, so draw your picture, and I recommend that at this stage you pause the video to gather your thoughts for a couple of minutes on how to find the equivalent capacitance. So hopefully you've worked on the problem, and what you should see is that C1 and C2 are in parallel. If that's hard to see, what you have to be aware of is that the lengths of the wires over here have no physical significance. So you can make them as short or as long as you want to. So if it's easier for you, redraw the picture like so. So what you see here is that I've just shortened up one of the wires, and I've represented C2 in this position over here. And now it's easy to see that C1 and C2 are in parallel. So once you see that they're in parallel, you can then draw an equivalent capacitor over here, which I've labeled as C12. To calculate that equivalent capacitance, you want to use this formula and then plug in the values, and you'll find that the equivalent capacitance is 15 microfarads. After you've reached this stage, what you want to do is recognize that these two capacitors, C3 and C12, are in series. So then you can redraw this picture in the following way. You can represent C12 and C3 as a single capacitor labeled C123. And now you use the formula for equivalent capacitance for capacitors in series, which is right here, and then plug in the values right here. One thing you want to try to do is not plug in these microfarads into your calculator too soon. So what I do is I factor out the micro part of it over here, and then this portion here is easy to stick into your calculator. So when you're done, you get some kind of number times by 1 over microfarads. But you know that micro is 10 to the minus 6, and then you have to do the reciprocal in order to find C123. So I just take the reciprocal of 0.317 to get 3.16, and then the reciprocal of the 1 over microfarads, which becomes this. And it's a lot easier to keep all of your numbers straight on your paper. So that's it for this problem.